Welcome to the Padhai Kar Lo JEE preparation channel. You can practice more problems on this exact topic on our Padhai Kar Lo Android app, link in the description below, or on our website padhaikarlo.com. Today's topic is the cube roots of unity, the three solutions to x cubed equals 1, and the powerful complex number omega built from them. Let's begin. To find the cube roots of unity, we solve the equation x cubed equals 1 or equivalently, x cubed minus 1 equals 0. Factoring this using the difference of cubes identity gives x minus 1 times x squared plus x plus 1 equals 0. So either x equals 1 directly, or we solve the quadratic x squared plus x plus 1 equals 0 using the quadratic formula. Solving that quadratic gives x equals -1 plus or minus root -3, all divided by 2, which simplifies to -1 plus or minus I root 3, all divided by 2, giving us the three total cube roots of unity, 1 and these two complex conjugate values. The two complex cube roots are conventionally labeled omega and omega squared, where omega equals -1 plus I root 3, all divided by 2, and omega squared equals -1 minus I root 3, all divided by 2. Notice these two complex roots are a genuinely complex conjugates of each other. Omega satisfies two genuinely fundamental, extremely useful properties. First, omega cubed equals 1 since it is itself a cube root of unity, and second, 1 plus omega squared equals 0, which follows directly from the quadratic equation x squared plus x plus 1 equals 0, that omega satisfies. These two identities, omega cubed equals 1 and the sum of all three roots equals 0, are genuinely the single most important tools for simplifying any expression involving omega on the JEE. A genuinely classic JEE technique uses these identities to simplify high powers of omega instantly. Since omega cubed equals 1, any power omega can be reduced by simply taking the exponent modulo 3. So omega to the power 100 equals omega to the power 100 mod 3, which is omega to the power 1 since 100 divided by 3 leaves remainder 1. A frequently tested trap involves geometric interpretation. On the complex plane, Argand plane, the three cube roots of unity are genuinely positioned at the vertices of an equilateral triangle inscribed in the unit circle, each separated by exactly 120 degrees. This geometric fact is exactly why omega is so useful in problems about rotations and equilateral triangles in coordinate geometry. Also remember that omega squared is genuinely the complex conjugate of omega, and that omega squared equals 1 over omega, since the product of all three roots, 1 times omega squared, equals 1, a direct consequence of the roots satisfying x cubed equals 1. Let's recap. The cube roots of unity are 1 omega, and omega squared. Solving x cubed equals 1, where omega equals -1 plus I root 3 over 2. The two key identities, omega cubed equals 1, and 1 plus omega squared equals 0, let you simplify any expression or power involving omega. And geometrically, these three roots sit at the vertices of an equilateral triangle on the unit circle. That's the cube roots of unity. Keep the two key identities, omega cubed equals 1 and 1 plus omega squared equals 0 sharp. They unlock nearly every omega-based question in this chapter. If this video helped, please like it and subscribe to Padhai Kar Lo for more JEE preparation content just like this. See you in the next one.